Hi, welcome to today's live stream for the 2020 Vision Hack with ADLINK and Intel. I'm Paul Wheels, your host. How are you doing? I'm a developer evangelist and product manager for ADLINK. Today, we're going to be having a chat with my colleague Niels Kortstee, who's a product director for the ADLINK Edge platform and solutions. Hi, Niels. How are you doing? I'm going to bring you in right about now. Hey, how are you doing, man?
I'm good. How are you?
Yeah, pretty good. It's nearly the end of the week. Hack's going really well. Getting loads of great questions from the teams. If anybody has any questions for this live stream today and what we're talking about, please do make the comments in the comments, and we'll try and answer them live to you. So, Niels, you're going to give us some insight into the Edge platform and SDK. Can you tell the viewers a little more about Data River? You know, we talked about the Edge platform a couple of weeks ago, and we mentioned Data River. So, can we get a little bit more detail around the Data River?
Yeah, sure. So really, the Data River is kind of the glue that brings it all together. So if you want to build a solution, a machine vision AI solution, in the end, it's about, okay, what's the ROI that I'm looking for? And typically that's about, okay, what action do I need to go and drive? And then you kind of reason your way backwards to, okay, but to be able to take that action, what decisions do I need to make? What information do I need to make those decisions? And where do I get the right data from? So it's all about, I need maybe a little data from different sensors. Typically, for the vision story, we're talking about a vision sensor, like a camera, ingesting that into in real time, and then streaming it to somewhere where you can process that and perform some analytics on it, so some AI on it, and based on the outcome, you make a decision and you drive an action out of that. So it could be as simple as showing something to human eyes of just flashing a red or a green light, but it could also be something like stopping a robot or sending a text message. So those are the kinds of actions. And the Data River is really allowing you to get all the data from the sensors at the right time to the right place, because you may be running your inference engine onto a different device. And you may need to do some interaction with a human or with some equipment on your factory floor somewhere else again. And the Data River really enables you to connect all these different assets and sensors and different devices that you deploy, and get all the software components wherever they are deployed in your network to communicate with one another. So you can actually do that whole processing from sensing to processing to acting.
Okay, brilliant. So, and how does the platform utilize the Data River?
Yeah, so that Data River, so like I said, that's really the glue that allows all the different apps to communicate with one another. So what we've done is build a whole platform, a whole range of apps on top of that are utilizing the Data River to communicate with each other, right? So we have a software development kit, the ADLINK Edge SDK, as we call it, and all these different apps that you see in all these different categories have been developed, have been added, and they are all integrated through the Data River. So all these different capabilities that we have, we're talking from, for instance, Vision Connect when we're connecting to vision sensors, when we're talking, for instance, about OT connectors to talk to equipment on your factory floor, or cloud connectors to communicate with any cloud out there. But by using the Edge SDK and all these apps utilizing the Data River, all these technologies can effectively be integrated into a single solution. So they can all talk to each other and exchange information, no matter where they are deployed. So what we've done with the ADLINK Edge as a platform, that's what we call it. We've basically said we've got all these different apps that you can deploy onto various devices. We've got a whole device management solution around that with our ADLINK Profile Builder that allows you to build a profile for your devices and say, well, here's the apps that I want to combine and configure and run onto specific devices. Then deploy that, including the configuration, onto the device or devices that you have in your network, and take it from there. And all these apps that we have built, we have collected in what we call our marketplace, which is really a Docker hub, where all these apps are stored, and if there's a new version, it's updated in there, allowing you, using the profile builder, to just select the apps that you need to build your solution, and deploy them, and kind of take all the building blocks, all these different building blocks together, and combine the integration with all these partner solutions that we support, and build your solution really quickly without actually writing a lot of code yourself.
So with the value of excuse me, edge computing, you're getting the benefits of the latency and bandwidth, as also potentially with the reduction of data transit in cost with that as well. Because you're enabling the computing and sending the data that needs to get sent, but enabling the computing at that edge. So can you give an example of how we do this with Vision, and how we build a profile, and what a profile is with the applications?
Yeah, it's a really good question to make it more concrete, right? So what you typically see if you build a machine vision AI solution, as we typically call it, you typically need a couple of components, a couple of apps out of the whole range of the ADLINK Edge platform. So the first thing is really, you need the profile builder, which is the tool that I just mentioned, to be able to build these profiles and kind of select all the apps and deploy them onto a device. So that's kind of the first step, is to configure all these apps and deploy them. So what apps do you need for that? Well, the first one would be we call our frame streamer app. It's able to connect to any camera. So for instance, with Visi, it could be connecting to a USB webcam, but it could also be some RTSP stream, or maybe some industrial camera that you have, to ingest the camera feed and make that available on the data river. And by doing that, you effectively make the real-time camera footage available on the data river for everybody to consume in real time. So the next step would then typically be, okay, I need to build a model, because I want to process the camera feed. I want to process it and run an AI model on it. But in order to do so, you need the training data. So once you've done the first two steps, you can use the training streamer, which is part of the ADLINK Edge platform as well, to get the live stream from the data river and push that into your favorite machine learning framework that you want to use, and use that to build and train your AI model. And once you've got a first version ready, we've got our model manager app that allows you to deploy the model at the edge. So instead of running the model in some cloud, you really want to run it close to the source of the data, really what edge computing is about, especially if you consider the amount of data coming off the camera and the ability to make real-time decisions. You really want to run that on the edge. So the model manager allows you to take that model, and then by using the profile builder, you can take the model from the model manager and deploy that into the Intel OpenVINO inference engine at the edge. So this is a separate app that it will be discovered by the profile builder once you've deployed it. It will also figure out what model managers you have. If you have your model manager, it will detect the model. You can then just drag the model onto the inference engine, and it will be deployed in real time. And from that point forward, the OpenVINO inference engine will just consume the real-time video and do the real-time inferencing, and publishes the results back onto the data river. And then by using the stream viewer, you can effectively look at, okay, what does the real-time video and the inference result look like? But also by combining it with a model confidence app, you can measure the accuracy of your model. If the accuracy is not good enough, you can basically go and go through steps 3 till 5 again until you're happy. And once you've got a model that's working, you feel like this is accurate, this is the level of accuracy that I need, then it's about, okay, what do I do next? How do I make a decision on that? How do I take action? So you either want to maybe connect to a cloud, so you can take some action there, or you want to connect to factory equipment. So we've got our various applications there to connect to OT equipment using OT protocols like OPC UA or Modbus. to connect to factory equipment and take action there. And finally, you may want to record your results or your actions for traceability purposes.
Yeah.
That's what we typically see. And then finally, you may want to extend your solution with some additional capabilities, right? Okay, what do you do if something that you need does not exist yet? You can actually build your own extensions using the Edge SDK. So that's kind of how you kind of form a machine vision AI solution.
And I mean, here's a great example of one of the solutions that we've made with some partners here. Do you want to sort of put this into context with what you've just shown there on how the connectivity with the camera, the model, and then the reaction with the lights?
Yeah, that's a great point, Paul. So here's just an example of a deployment. So in this use case, there's one industrial PC with two industrial cameras connected to it. One you can see on the right-hand side, scanning the barcode on the side of the box. So it's effectively using a model. It's actually using traditional machine vision for that. So it's not using an AI model for that, but to recognize the barcode. And with the Edge SDK, a custom connector has been built to integrate with the warehouse management system to pull the manifest that belongs to that barcode and figure out what should be inside that box. And then the second camera that you see here does run an AI inference model onto that live video stream to recognize what's inside the box. And then the action really is, okay, let's match what I see inside the box to the manifest, which tells me what should be inside the box. And if it's correct, I'll just control the lights on the left-hand side you just saw flashing green to say, yep, the contents are matching the manifest, or a red light saying, no, it does not. Maybe also control the conveyor belt further down the line to push the box off if it doesn't have the right content in there. So you can see all these different components that I mentioned around, getting access to the real-time video with a frame streamer, streaming that into an AI model that has been trained to do a specific task. In this case, it's about recognizing the contents of a box for auto validation. And looking at the inferencing results like you see here on the screen, and then taking action. So this is really just an example of what this solution that I showed in general can do. But you can plug in any AI model that you like. You can plug in any action that you like. You can connect one or multiple cameras. You can deploy on the camera itself if it has storage or compute, or just connect the cameras to an industrial PC or a developer kit or whatever. It doesn't really matter for the architecture. Because of the data river, you can deploy anywhere. And these apps just run and communicate with each other. They discover who else is there and start talking.
Yeah, and on this example as well, correct me if I'm wrong, but one of the things it does is you were talking about the historian collection side of things. Of it takes a picture of the box as proof that it was correct. That if there's ever any discrepancies and checks and stuff, so it enables you with that single image rather than a continuous video stream to log the activity.
Yeah, exactly, Paul. Sorry for interrupting. Yeah, that's indeed what it does. One of the concerns that is for this use case was customers coming back and saying, I ordered X, Y, and Z, but you actually only shipped me X and Y. And then they could just go back and say, look, here's an image that we took after we put the order together, and actually Z is also in there. So something must have gone wrong after we shipped it.
Yeah. So let's go back to, thanks for that. That was absolutely brilliant, and I hope it was insightful for everybody. As I mentioned, anybody got any comments, please do post them, and we'll answer any questions. So the SDK. How do people access that? How do they start to think about building an SDK to become part of the marketplace?
Yeah, so like I said, there's already a wide range of pre-built capabilities available in the Edge platform. So for those things that exist already, you just want to pick what's available off the shelf. But I also recognize that you need some customization for specific use cases, or you may want to build some extensions. The Edge SDK allows you to basically build your own apps that integrate with the data river and basically get access to everything that already exists. So all these pre-built capabilities you get access to if you use the Edge SDK, and allows you to build your own apps. And yeah, like I said, data river is based on proven open standards. It has built-in security. It's also fully portable, so it runs on a wide range of different operating systems, but it also runs on x86 and ARM hardware architectures. And by using the SDK, you also make your component location independent. So what I mean with that is, like, if you develop an application and you feel like you're going to deploy it on one device or on another device, nothing needs to change in the application code or in its configuration. So that's the power of the data river. Allowing you to scale easily and also to extend your solution easily. One of the pains that I often see is people build something, and then the next step is, oh, I'll build this new extension. Oh, I need to add a new device to it, and oh, by the way, suddenly some of the data that one of my existing apps is sharing needs to go to another location as well. And even if it does that, well, it doesn't really scale well, and I need to change the configuration, and I need to change how things operate, effectively making it very expensive to extend your system and to evolve it. So the Edge SDK and the data river have been designed to make that a lot easier and make that cheaper.
Brilliant. And it's very much about the configuration, less code, focusing on the AI side of things as technology has evolved and demonstrating the value of Edge, as you said. Here's some great links, and I've shared them in the comments as well for everybody to be able to access them on getting started. Do you want to just give a quick overview of these different areas here?
Yeah, so I think the first bit is about VGI. So you've all received your own Visi now, and for people that are tuning in that don't have one, you can easily get one off arrow.com for $199. Can get started easily. And the guides that I'm pointing here to is, okay, well, depending on the operating system that you use on your own host machine, you can get started with Visi, set it up, get going with the ADLINK Edge platform. With the second link, it shows you a bit about, okay, how can I use that profile builder? So there's a whole nice video on YouTube that has, or it's even a playlist with a lot of videos showing you how to use the profile builder to build your profiles and deploy apps onto the Visi AI or any device, really. And then the next step would be, okay, well, you've got your software deployed. How do I now build and deploy my AI model? So that's where the third bullet is about. How do you package your model to work with the OpenVINO app that's already available? So for a lot of these cases, it will be about, if you have a camera connected, the whole workflow of acquiring the image and streaming it into the inference engine and getting the inference results, there's already pre-built software available to do all that. The only thing you need to do is plug in your AI model.
Yeah.
And then for the bits that you want to add and customize your solution, you can get started with the Edge SDK. So the last bullet is about, okay, why do you want to use it? How can you use it? Where can you get it from? How do we install it? What are the concepts in there, and all the functions in there? So there's a couple of links here as well. So there's actually also a training deck available, and maybe that's something we can share as part of this live stream, Paul. I don't know how we do that, but there's a big PDF that you may be able to share with the viewers so that they can learn more about the concepts and get how they get started quickly.
Yeah, we'll make that PDF accessible today and share the link with everybody. Just to put you on the spot a little bit, as I like to do, I know it depends on the complexity of the application that they're going to build with the SDK, but what kind of timescale are people going to have to sort of consider to invest in using the SDK to build an app? How long would it take?
So it depends a bit on do you have experience with software building. But if you do have some software engineering background, what I've seen is that people can actually get an app working within a day or so. That first real app that does something real. you're starting from scratch, learning, installing, and getting the app built within a day. Yeah, for sure.
Wow, that's brilliant. That's absolutely brilliant. Niels, always a pleasure catching up with you, bud. Thanks very much for taking the time to share your insight with everybody. You're
welcome.
We have more Meet the Teams over the course of the next couple of days. We have some fantastic Intel industry insights and live demos coming over the next couple of weeks, and a lot more coming through. Let's have a look at the prizes that people are hacking towards.
Phase 1 winners will receive an ADLINK Visi AI Developer Kit, which is a bundle of powerful hardware and software to build your prototype with. The hardware is a Smart 2 board, which is industrial ready. It has a 4GB RAM, an Intel Atom 3940 CPU, and an Intel Myriad X VPU, so plenty of power for AI vision. The Visi AI also has very intuitive software included with it, the ADLINK Edge platform, which has vision tools, and OpenVINO and Node-RED included. As a Phase 2 team member, you will also receive direct support from Intel and ADLINK whilst you develop your prototype, so don't worry about support. The final prize. The winning team will win a cash prize of $10,000, but we don't stop there. An amazing opportunity to collaborate with ADLINK to validate the prototype with the market. That will include support in creating marketing material like a press release, a promo video, a use case, a solution brief, and the support with organising meetings to validate your prototype with the market. This gives you a great foundation to really push forward in making an impact with your prototype. I think you agree this prize could be life-changing for you and your team, so good luck.
There we go. They're the prizes that everybody's hacking towards, and we'll be announcing the winners Phase 2 in April. Niels, thanks so much for your time again, and goodbye.
Cheers, Paul. Bye-bye.